All right, I'm going to go ahead and get started now. All right, so my name is Ashley Puls, and I will be talking to you today about troubleshooting live Java web applications. I am a senior software engineer at NewRelic. NewRelic does provide an application performance monitoring solution. You will see it in the slides today, but it won't be the only performance tool that I'll show. We're going to cover a couple different tools and go over pros and cons of them all. So I want to start out by talking about troubleshooting, right? It's the first word in the title of my presentation. And so really we should probably first cover what it means to troubleshoot. I've listed a few definitions here. Generally you can see in pretty much every definition there's the locate or find the trouble, right? And then the second aspect of troubleshooting is to solve that problem. And so one question is, how do you become a good troubleshooter? Well, one, you have to practice. Just like in tennis, you have to practice your serve over and over and over and over and over and over again. You need to practice troubleshooting over and over and over and over and over again to really become good at it. Second, you need to have a good set of tools. Without diagnostic tools, you won't be able to find the problems that you need to find in your application. And this is really what we're going to cover today, is hopefully enhancing your toolbox so that when you leave here today, you can add at least one new tool to your toolbox. So we're going to work with a web application that has multiple performance problems. We'll troubleshoot the problems, and we'll talk about the pros and cons of each tool as we go through the troubleshooting process. So first, we need an application. Now, I'm a runner, so I'm going to pretend for our hour and a half today that Max Siegel, CEO of the U.S. Track and Field, came to us with an application called Running Central that he would like us to troubleshoot. So let's go look at the application. So here's the application. It has a Prefontaine there on the front, and it gives you the ability to do a few things. You can search for runners. So we could search for runners with the last name Bally. Then we could click on one and see their last race. We can add runners. So I'll just add myself here, and I'm from Portland, Oregon. We can search for teams, so I can go ahead and search in Oregon and find all the teams there. And I can search for races. Maybe we want to find a 10K. And you'll see all the races appear. So essentially you have a website that's searching, adding runners, etc. Here's a little bit of an overview of what it looks like. We have clients. They're connecting through JSPs. They can also connect through servlets to upload data. The Spring MVC framework's being used here, so we have controllers, we have managers, we have entities. Hibernate's being used in there with a MySQL database, and then it's all running in a Tomcat application server. All right, so we have our application. Are we ready to just jump in and start troubleshooting? Well, if you look at the picture, I think not. So let's go take a step back and think about what is trouble. My computer's not on fire, so everything's good, right? Well, not exactly. I would say trouble. If you can't even access your site, that's trouble. If you have exceptions in your log, that's probably another good sign that you're in trouble. If your site's running slowly, that's a good sign of trouble. Now the next question to ask is, how slow is too slow? So maybe what we should ask next is, what is normal? In baseball, Lots of statistics are kept on each player, so you can know exactly if they're performing on average during a game, or if they're really exceeding and hitting lots of home runs, or if they're really having a quite poor game. So I think we want to do something similar in web applications. We want to be able to tell what is normal so we can tell what is abnormal. So the next thing we want to look at is, what are the stats? You know, in baseball, there's your batting average. So what are the stats that are important to a web application? Now, I've listed 6 stats here that I think are pretty important. So the first one's errors. What exceptions are being thrown in your application? How frequently are they being thrown? Application response time. This one I would probably say is the most important. When you have a request, how long is it taking for that request to be handled for your users? Database response time. How long are your queries? Your thread state. Are your threads running all the time? Are they blocked a lot? Are they sleeping a lot? Garbage collection. Garbage collection can be a major cause of why your application is stalling a lot and being slow. And memory allocation. Are you running out of heap space? Are you running out of permgen? These, I think, are all important statistics, and so we're going to look at them today. Now, the next question is, how do you gather these statistics? Well, there's a variety of tools out there. Everything from your basic logs to very intense profilers that can gather a lot of statistics for you. And so we're going to look at a bunch of these today. And so I've created a chart. On the left here, we have all the tools we're going to look at. We're going to look at logs. I have app server monitoring. And that, I mean, what can you see in your admin console of your application server? We're going to look at NewRelic. We're going to look at Yourkit, jvisualvm, JConsole, jmap with jhat, and JStack. And then at the top here, so this is just providing some basic information. What's the tool? What's required to install it? Is it free? Is it included in the JDK? And then I have another chart that has our stats at the top. So we can go through and figure out what tools provide what of our 6 stats. All right, I think we're ready to talk to some of our end users and start troubleshooting now. So first, does anyone know who this is? Says right on his shirt, it's Usain Bolt, 6-time Olympic champion. Well, he was on the phone the other day, and he was complaining that he couldn't access any 5Ks on the site. So we better go investigate. So we're going to start with NewRelic. NewRelic is an application performance monitoring tool. It monitors web apps, mobile apps, servers, and databases. In order to use it, you need to go to the NewRelic website, sign up, download the agent, and then install it using the Java agent command. So it does require a restart of your application. So let's put it in our chart. It's an APM solution. It does require a restart of your application. The basic features are free, but the more advanced diagnostic tuning features you do have to pay for. It's a commercial product, so it's not included with the JDK. So here's what the basic overview page looks like. You can see the main chart on it is the application response time, and it's broken down into your JVM time and your database time. The other key stat of our 6 stats is the error rate is shown on the overview page. And I can pull this up. I'm in browser. Let me get to app. So here's just NewRelic running live with my running central application. You get the app response time and that error rate, and you can drill into that error rate to get any errors you're seeing. So I've had some 401s. So if you go over to the JVMs tab and you go into that, we can then get another one of our 6 stats. At the top, you can see the heap memory. And further down on the page is the non-heap memory. And if you keep on scrolling on this page, you'll get to the garbage collection. So this might be a good time to take a step back and just talk about JVM memory in general. So there's your heap memory. This is where your class instances are stored and your arrays. And if you look back on that chart of NewRelic, you can see the par Eden space, the par survival space, and the old gen. In case you're not familiar, so objects first go into the Eden space, and if they survive a garbage collection there, then they move up to the survivor space. And if they're still long-living objects, then they'll eventually move up to the old gen space. So we also have our non-heap memory. This is where the runtime constant pool is stored. Your intern strings, so there's on the string objects you can intern them, and generally that is used if you want to save memory. So if you're using a string multiple times all over the place, you can move it from heap and put it in your permgen space by using the intern, and then your field and method data is also stored there. There's also some other JVM space where the JVM internals is stored. So what are the common memory problems that you'll see in these? Well, for heap, if you have keeping references to old objects, right? So then they can't be garbage collection, so they stay around, and you'll see your heap start to spike up. Or if you have like long-running static objects somewhere, and you don't clean them up appropriately, you just add to them, that can also create memory leaks in your heap memory. In your non-heap memory, the most common problems are leaky class loaders. So if something's keeping references to your classes and you try to redeploy, those classes might stay around, and then you get the newly loaded ones and you'll see your permgen go up. Also, if you use intensive amount of intern strings, that can also cause an out of memory in your permgen. So looking at our memory page, here we can see we've had a spike in our memory. That yellow line is the max heap. The light blue line is the used heap. And essentially, our used heap has reached our maxed heap. So we need to go investigate. This is a problem, right? And what we'd really like is to know the objects in our heap. Now, NewRelic currently does not provide a heap dump, so we'll need to move to a new tool to get that information. So before we move, though, let's pull up our chart. We've seen the app response time for NewRelic, the error info for NewRelic, GC information, and memory information for NewRelic. So the next tool we're going to look at is jmap. Jmap will print the memory map of a Java process. It comes with the JDK. There's various options you can use with it. The two I'm going to show today are the -heap and the -dump commands. So let's start first with the -heap, but before we do that, again, let's put our information in the chart. So jmap, it prints our memory map of the Java process. It'll attach to a running process. You don't need to restart your application. It's included with the JDK, and so it is free. So I have my command here, jmap-heap. The 5317 is my process ID, and then I'm piping it to that jmap.out file. So I run that, it attaches successfully, and I'm good. Now, if your process is really in a bad state, I've before had trouble. Sometimes you just can't get it to attach. You can try multiple times and it just won't attach. So there you probably just need to move to a new tool. But this is what you'll see, and it's a little hard to see, I realize. But it essentially has, your new generation, your Eden, all your heap space memory, your non-heap memory. And sure enough, you can see the same thing here. So we're at 99.999% and 100%. So we've run out of heap memory. Now we still haven't gotten what we really want, which is a heap dump. So what we can do is we can use the -dump command with jmap. And this will print out to the heap_dump.map file. And again, the 5317 is my process ID. So I run that, it creates the heap file, I pull up the file, and it looks like this. So we need something else to read this. At least I can't read that. So that's where jhat comes in. Jhat is a tool that just reads heap dumps. So you just give it your dump, and then you run it. Now, how many of you have run the tool before and gotten this? Anyone? Yeah. Jhat uses a significant amount of memory in proportion to the size of your heap dump. So most of the time when you run it, you will have to increase the size of memory. So then you can run it, and this time it ran successfully. And this is what you see. So you go to pull up a browser, go to localhost 7000, and it'll show you all of the objects in memory. And if you scroll down to the very bottom of that page, you'll see the show instance counts for all classes. If you drill into that, you can see what objects, the number of times each object is in your heap space. So here we can see we have a lot of strings, and we have a lot of concurrent hash map hash entries. So this is a good sign that we have an exploding concurrent hash map somewhere in our application. So now we need to figure out where that concurrent hash map is. We can drill into the concurrent hash map entry, and this is what it'll show you. You get the superclass, instance data members, static data members, and at the bottom it has references to the object. We can pull that up, and it'll show you your key and your value. Now, if you're really familiar with an application, this might be enough information for you. You might be able to see the data and say, I know exactly where that concurrent hash map is. But if you're not familiar, you still might have no clue where your concurrent hash map is located. So I'm going to show you another tool, but first let's go back to our chart. Jmap, jhat, that's really just for memory, so we'll just give it a star in the memory column. And then we'll move on to Yourkit. Yourkit is a profiler. It provides very in-depth information into CPU, threading, and memory. And there's lots of profilers out there that you can use. JProfiler is another example. I'm going to show Yourkit today because that's the one I'm most familiar with. And it's another commercial product. So you have to go to their website, you have to sign up for it, you'll get a license key, and that's how you'll use the project. So it's a profiler. Depending on what features in Yourkit you want to use, you may or may not have to restart your process. Some of the CPU profiling and the exceptions, those require you to attach on startup, so you have to restart. Other information like a heap dump, you don't need to restart the process. You can attach after the fact. And you have to pay for all of its features. It's not included with the JDK. So when you pull up Yourkit, this is what you'll see. You'll see all of your Java processes, and the one we're interested in is the Tomcat one. You can double click and go into that one. And this is the overview page that you'll see. So you get your CPU time on the left and then your thread count on the right. There's an exception tab for all your error data. If you drill into the threads tab, you get all of your threads and what state they're in. Are they blocked? Are they sleeping? Are they waiting? Etc. If you go into the memory tab, you'll get your heap memory and your non-heap memory. There's a garbage collection tab. If you go into that, you get time spent in GC, your minor collections, your major collections, so lots of GC information here. And at the upper left-hand corner, you can run a CPU profile. And so this is the closest thing you're going to get to an application response time. This is going to give you timing information on all of the methods that have been running in your process. And you can look at them, and it's helpful for diagnosing and finding problems. There's also, on the left here, you'll see a SQL tab. And this will give you the times of your SQL statements. So this is your database response time. So if we go to our graph, we saw application response time, database response time, error information, thread information, GC, and memory. So it really gets a star in every category. Now let's go back in and get back to diagnosing our problem. If you go up, you can do a capture memory snapshot. And this is what you'll see. If you can read that, it says it's the class RayStat service impl is taking 42% of the heap space. And if you drill in, sure enough, there's a concurrent hash map in there. So we've finally identified the exact class where our concurrent hash map is located. So now we can go to our code and look in there to see what exactly is the problem. So if we pull up the code, the RayStat service impl, it says this service records stats on the cities and states queried by users when looking for races. And the stats are printed out to the log. And sure enough, there are two concurrent hash maps in there. There's the cities queried and the states queried. They're both concurrent hash maps. They're initialized in the constructor, and there's an add location method. So anytime someone queries for a city or a state, it gets added to that concurrent hash map. There's also a processor that it looks like it gets run once a minute in a separate thread. So let's pull that up. And this is an inner class of that RayStat service impl. So it gets access to those two concurrent hash maps. And if we look here, nowhere are we ever removing from these concurrent hash maps. We are just constantly adding, and here we're printing out information. So one thing we could do is we could remove the data after we print it to the log. Now this is still a little not great, right? We don't really want to trust everything that users are querying for and be storing it and necessarily printing to the log. But this could help with our memory issue. I mean, we're still storing everything that's queried for a whole minute. So if we have 1 million users query for 1 million different things in that minute, we're going to have to store all 1 million strings. But the general idea here is you need to clean up memory and long-running objects. And if you clean it up, we can go back and look. This is jmap here. Whoops. And you'll see we're about 50% on our memory now, so we are in a much better place. So let's move on. Does anyone know who this is? This is Paula Radcliffe. She is the female marathon world record holder. And she was in tears the other day because she couldn't find her fellow runners on the website. So we need to do some more investigating. So the first tool we're going to look at now is jvisualvm. This is a visual tool. It does your heap dumps, your memory leak information, your garbage collection monitoring, your memory profiling, and your CPU profiling. It's included with the JDK. It attaches to local and remote processes. So it does do your CPU profiling, so it is classified as a profiler. It attaches after the fact. You don't need to restart your process. And since it's included with the JDK, it is free. So when you pull up jvisualvm, this is the screen you'll see. And on the left there, you'll see our Tomcat process. If you double click on that, you'll get this screen. You'll see your CPU usage with your GC activity, heap perm gen, threads in the lower right, classes, counts in the lower left. So our GC information, that was one of our stats we were collecting. Our memory information, that was another one. And our thread information. So we have 3 of our 6 key stats on the front page. We can drill into the Threads tab, and that'll again show all of our threads and what state we're in. Now here you see a lot of purple. What is purple? It's sleeping. Having your threads in a sleeping state is not really necessarily a good thing, so it's probably something we want to investigate. So in the upper right here, there's a button, and this will allow us to do a thread dump. So if we click on that, it'll take a little bit of time, but then it should return the stack trace of every thread in your JVM and where it is at that exact moment in time. And so here, what we found, all those purple threads, they were sleeping in the exact same spot, and it was in the runner stats service impl add entries method. Now this here is enough information for us to go to our code and figure out exactly what's going on in that location. But one question to ask is, what if we don't have the ability to use a UI? Sometimes, you have to SSH in your servers and you just can't use UIs on them. There are a few terminal commands that we can use, so we'll cover that next. But first, let's put our data in. So jvisualvm, it does have a CPU profiler, so we'll count that for the application response time. We saw the thread info. In fact, that's where we just were able to get our information to know exactly where we needed to go in our code to find our problem. It had GC percentages, and it had basic memory information. So like I said, if you can't use a GUI, then you can always go to the terminal and do a ~3. Now this is for Linux and Macs. The Windows equivalent is a control break. And it'll give you a thread dump, so you'll get the stack trace of every thread in your JVM. Another terminal tool is JStack. This comes with the JDK, and the main difference between JStack and a ~3 is that this one comes with the JDK, so you can run it on any operating system, and two, JStack can be used for local or remote processes. And so you do JStack, your ID, and then you can pipe it to a file. So I have JStack here in our chart. It prints the thread dump. It attaches after the process is started. There's no need to do a restart. And since it comes with the JDK, it is free. So here I have JStack with my process ID piping it to a file. And I open up my file, and sure enough, I get the exact same information that I got in jvisualvm, right? In the runner stats service impl add entries method, there's a sleep, it looks like, where our threads are all sleeping. So JStack, it really just provides that thread information, so we'll just put a star in that column. So next, let's show NewRelic. I'm going to skip over this slide since we've already seen NewRelic once, and go into the threads. We here on, this is the JVM tab, we can get the thread count. Now this doesn't really show our thread dump, right? But if we go to events, and then we go to thread profiler, there's the ability to do a thread profiler. And you can run for various amounts of time. You just hit Start Profiler. It'll run. You'll see this screen for the amount of time you've selected. And then you should see on the right your thread profile. You can double-click on that. And this is what we get. So this shows us where are the threads going, what methods are they calling, and what percentage of the time are they taking that route. So here we can see that all of our threads are going into the runner controller search runners method. 89% are going into that runner stats service impl add entries method. And all of those 89% are sleeping. So this gives you slightly different than a thread dump, but it gives you similar information, right? You can still see a significant portion of our threads are sleeping in the runner stats service impl add entries method. So we'll add thread info to our chart, and then we'll pull up the code. So what this is this the runner stats service impl. It says it stores stats on the last name of runners which have been queried. So if we go to the bottom there in that add entry, sure enough, we can see a sleep method. And it looks like what's happening is that there's an array blocking queue that's set hard-coded to 100, and then in the add entries method, we're just waiting. If we can't offer the information, then we sleep. Now this is very, very poor coding. All of this code should probably be torn out because these are requests coming in and we don't know how many requests we're going to get each minute or however long we're storing these in until we're pulling off the queue. We don't want to really be setting this to any finite value. And another question to ask here is, again, do we really trust our users? Do we want to be storing every string that they're querying on and storing it and logging that information? So the main thing here is that you don't want to block threads. Whether it's sleep or whether you block on the actual collection object, you want to be very careful not to have your threads in a block state. So if you clean up all that code, and we do another stack trace, thread dump, now we can see that our threads are waiting for more requests to come in. So this is a much better place to be, right? Because as soon as a request comes in, one of these threads can be used to process that request. So we're no longer sleeping in that add entries method. So let's move on to another user. Does anyone know who this is? This is Patrick. He's the marathon world record holder. And he was in a press conference when he was talking about how he couldn't find marathons on the website. So again, we better go investigate. So this time we're going to go ahead and start with NewRelic. And on the JVM threads page, it'll show you your thread pools. And here we have the 8080 thread pool. On it, you'll see a red line. That red line represents the max number of threads that you can have in your thread pool. The turquoise color is the idle threads, and the yellowish orangish color is the active threads. So you can see from this chart that we are maxing out our threads. All 75 of our threads are active. So this is problematic because it's probably meaning that there are other threads that are, or requests that are waiting to come in and are probably blocking because they can't get a thread in the thread pool. So we could there probably just go increase our thread pool, but because this is a presentation on tools, let's see if we can find that same information in some other tools. So next, we're going to look at JConsole. JConsole is a graphical user interface. It does Java Management Extension metrics, JMX metrics, and it can show you metrics for local or remote JVMs. Now, one thing here is that in order to see these metrics, you need to have JMX metrics enabled for your application server. Now, this application is running on a Tomcat application server, and JMX metrics are enabled by default. But for example, if you're running Jetty, not all versions of Jetty have JMX enabled by default. So you would have to go and turn those on. There's a JMX XML file that you need to put in your configuration file for Jetty to enable those metrics. So let's add JConsole to our basic information chart. So it provides JMX metrics. It attaches after the fact, so you don't need to restart, and it comes with the JDK, so there's no cost associated with it. Now, for anyone who's not familiar with JMX metrics, I'd like to just do a brief little explanation of what they are. So JMX metrics provide metrics from managed beans. Managed beans are remotely accessible interfaces into resources, and they provide stats for those resources, and they also give you the ability to manipulate those resources. Examples, applications, JDBC drivers, garbage collection mechanisms, thread pools, and there's a core JMX metrics that are provided with the JDK, And each app server generally also provides a set of JMX metrics, and those are very different. They change with each application server, so it really depends what application server on what JMX metrics will be provided by default. But those MBeans, they talk to an MBean server. They register really with the MBean server, and the MBean server acts as an intermediary between the MBeans and any application requesting that information. So when we use JConsole, it will connect through a connector and adapter to the MBean server and provide you with those MBean metrics. So now let's pull up JConsole. Here you can see the JConsole process running, and the bootstrap there with the start, that's our Tomcat process. So we'll double click on that, and this is the main overview page you'll see. Now this is similar to some of the other tools pages. You get the heap memory usage, the threads, the classes, the CPU usage. So for us, our key 6 metrics, memory is one of them, thread information is one of them. And we can also drill into the threads tab, and again we'll see each thread and we'll get a stack trace of exactly where that thread is in the code at that moment in time. So next there's the MBeans tab at the top. If we drill into that, you'll see this is where you go to actually see your JMX metrics. So the java.lang, those are your JVM specific MBeans. It tells you the basic information. In the overview page, all those metrics are actually pulled from here. So this is where you get your garbage collection, your threading, your memory, etc. At the top, that Catalina, this is our Tomcat application server MBeans. Now if you rename your server and your server.xml, it won't be Catalina, it'll be whatever you renamed it. But Catalina is the default, and I've left that in the server.xml, so that's what we see. And we can open that up. There's a whole bunch of metrics here, everything from caches to resources and servers. But the one we're interested in right now is the thread pools. So if we open that up, we see that HTTP bio 8080. And we can look at all of its attributes. And here we see the max threads are set to 75, and the current threads busy is also set to 75. So this is providing pretty much the same information. We can see from here that we've maxed out our thread pool. So JConsole provides you the thread information, provides you the GC information, and provides you some basic memory information. Now one question some of you might be asking is, can't you do this all with jvisualvm? Isn't jvisualvm the tool that is supposed to replace JConsole, jmap, and all those tools? Well, the answer is yes, but you don't just automatically get the MBeans tab. You actually have to go up and install a plugin to get that tab. So if you, in jvisualvm, you go up to Tools and you select Plugins. And this is what you'll see. You'll want to go to the Available Plugins. And there should be a JVM MBeans plugin. You select that, you install it, you'll have to restart jvisualvm. And you should then see this MBeans tab. So this is the exact same tab we just saw in JConsole. If we go into it, we see the same metrics, the JVM specific MBeans, the Tomcat application server MBeans. And we can drill into that Catalina, go to the thread pool, go to the 8080 thread pool, and here we see the exact same information again. The max thread, 75, concurrent threads busy, also 75. So multiple ways to get pretty much the same information. So next, how do you go and increase the number of threads in that 8080 pool? Well, you go into your Tomcat config server.xml. And there should be a connector with 8080 in there, and sure enough, you can see we're set to 75 threads. So this is where you'd want to go and increase your thread pool. So the next question you might ask is, what number should we set that to? Do we just pick some really large number like 1,000, or how do we set that? Well, you do need to tune them. It's not just pick an arbitrary value and go with it. So as we saw, you don't want your thread pool to be too small, right? And just like in the airports, most of you probably traveled here, you might have sat in a security line. If there's not enough security personnel, you sit there, you sit there, you sit there. You don't want your thread pools to be too small. On the same side, you don't want your thread pools to be too large. Then system resources might become exhausted. So going with the airport theme here, there's only so many thread detectors, metal detectors, at the airport. So only so many concurrent people can be going through these at the same time, right? Additionally, there's only so many TSA officers that can be herding people through these metal detectors. So for us, the limiting factors are memory, right? Each time you create a thread stack has to be created. In Spark, for example, in the 32-bit VM, 512K is the default amount allotted for a thread stack, and 1024K is the default allotted for a 64-bit VM. So you need to be conscious of this. If you're going to increase your thread pool to a larger number, you have to have enough memory to be able to handle all those threads. Additionally, you have to be concerned about the number of CPUs. If you have a lot of threads and a really small number of CPUs, you're going to reach a point where your CPUs are spending more time switching between threads than actually processing the work on those threads. So there's a lot of information on queue theory out there and how should you tune your threads. I'm just going to talk about one law here, which is Little's law. And what this says is if you take the average response time for a request, so this would be roughly our application response time, and you multiply it by the average arrival rate of your requests, then you should get the approximate size of your pool. So one thing is here, this would have to mean that you all have a fairly constant number of threads coming in, right? If you have a very spiky application, this isn't really going to apply. But if you do have a fairly constant number, this is something that can be used to help you tune your thread pools. So we've tuned our thread pools, we fixed the issue, we can go back in, and we have max threads at 300, concurrent threads busy at 200. Things are looking a lot better. We're not having issues anymore. So great. So let's move on to our next runner. Anyone know who this is? It says right on the front there, Carmelita Jeter. She is the fastest woman alive in the 100-meter sprint. And she was complaining that our site was taking longer than her team's 4x100 world record time. So we better go investigate. So first here, I'm going to start with the application performance monitoring. So most application servers have an admin console, and in this admin console, generally some performance information is included. Now the quality varies between admin consoles. Tomcat, for example, does not provide a lot of tuning information. Glassfish, on the other hand, provides a lot more statistics for you. So app server monitoring, it's the admin console. It varies significantly. Generally, it's on by default. For Tomcat, for example, you need to add a user that has the GUI privileges to see that information. So if you don't have that enabled by default, you'd have to go restart after you added that. Generally, the admin console comes with your application server. I don't think you have to typically pay for it. So this is what you see on the Tomcat one. So really, the only information you're getting here is the memory information. Oops. You also, at the bottom there, you can see your gets and your posts as they come in. But this really doesn't provide much information for troubleshooting. there's really not much there. Additionally, it will show you all of your wars that are deployed. Again, it's not really that helpful for troubleshooting unless your war is just simply not deployed. Not going to provide that much. So for the Tomcat one, all it had was some basic memory, so that's the only star that I'm going to give it there. And we're going to move on to NewRelic, and we're going to look at the Databases tab here. So in NewRelic, on the Databases tab at the bottom, you can see the response time of your slow SQL queries. NewRelic also gives you the ability to drill in, so we can drill into this one that's taking 3 seconds. And it'll give you your SQL, it'll give you some query hints, and you'll get a stack trace of where exactly that SQL statement was called in your code. So this can be helpful for figuring out exactly where in the code to go. So here we're doing a last name like statement. There's a lot of outer joins in our query also. That's something that can be fairly typical with Hibernate applications. And here in the query hints, and it's probably a little hard to see, but it says no index was used in this part of the query. So we don't have any indexes, so it's having to do a full table scan. So that's why it's taking so long. So we could at this point go add an index, and here we'll add database response time, a star for that. But I'd like to show you another tool first, and this is logging, right? There's a variety of logs out there for you to look at. There's your application logs, your application server logs, and your database logs, and sometimes frameworks themselves will have their own logs too. Generally, the information provided in these varies significantly. It's really how much time the developer decided to devote to logging and what they thought was important, right? And there are tools out there. I won't show you any screenshots of them today, but Splunk and Loggly, for example, are tools that you can use to analyze your logs. So logging, it's generally turned on at some level. There's generally properties files, so you don't have to restart to get a higher level of logging. And it's generally free. You don't normally have to pay extra for logging. So we'll start by looking at the application logs. Again, this is going to vary significantly between applications. Here we don't really see too much information to help us with debugging. We are showing all the races that are being added. So if someone came and said, you know, this race wasn't in the database, we could go look at our log and see if it was ever added. But beyond that, it's not going to really provide us too much debugging information. If there was an exception thrown, we'd probably see that here. But one thing we can do if we want to get some timing information is we can use Spring AOP. So to use AOP, if you're not familiar with it, you create an aspect. And what I'm doing here is I have one method that's wrapping my method calls in the manager layer, and it's essentially just timing that layer. So here, this at around with the execution, that's saying time all the methods in my manager layer. And then here you can see where I'm actually doing the timing. And I'm just printing that all out to the log. So now you can see for anytime a manager method is called, that information's getting put in my log. Now this is still, you need to parse it, you have to figure out, you probably want to take averages and not specific examples. So there's still a lot of work here that needs to be done. But we at least have some timing information. So let's move on to the application server log. There's the host access log. So this is going to show all of your gets and all of your posts. Here you can see all of them look like they have a 200 on them, so that's good. But if they came back with an error message, we would be able to see that here. Also with Tomcat, there's the Catalina.out. This is printing everything that gets printed to system out is going to go in here. And one thing you can see is that Hibernate, I'm having Hibernate print out all of my queries to this log. So how do you set that up? Well, if you have an application context.xml, the property is hibernate.showSQL. You set that to true, and that'll start printing out your queries. If you don't like the format, you can do the format_SQL, turn that to true too, and you'll get a little nicer format in your logs. You can also do this hard-coded in the code if you'd prefer to, or if you're not using an XML file. So next, let's move on to the MySQL logs. The only log that's turned on by default for MySQL is the error log. So this will show you exceptions. Since we're not really throwing many exceptions, this doesn't really provide us much information, especially just for troubleshooting. So you can go and turn on, there is a slow SQL log in MySQL. To turn it on in your configuration file, you have to add slow_query_log. And you also have to set the property long_query_time. And the one thing here is that long_query_time is in seconds. Now generally 1 second is a long time for a query, but unfortunately you don't get any millisecond variability there. You have to set it to 1 second or 2 seconds. You can't set it to 500 milliseconds, etc. So it's only going to really grab your really, really slow queries. But if you do that, this is what you'll see. You'll get some query time. You'll also get the number of rows examined. And you should see the query yourself. So here, this is the same query that we saw in NewRelic. It's a last name like statement. So clearly we have an issue with that query. But let's, here in our graph, add logs. So app response time, we basically got that by using Spring AOP, right? You can wrap your controller methods and get timing information from it. Database response time, we got that from our slow SQL log in MySQL. And error info, pretty much all of the logs, they're going to provide you some error information if there's an exception thrown. So how do we go about fixing this? Well, one thing is we could go into MySQL, we could go into our database, and we can do an explain plan. So how do you do an explain plan? You add explain in front of your query. I add /g on the end. It just prints it out to a nicer format. And this is what you can see, and this probably is too small for you to read, but essentially there's a row for every table name that was specified in your query. So we had 4 different tables that were being joined, so we have 4 different rows here. Now if we drill in to row 1, that's the runner table, and the possible keys and the keys. So the possible keys are any indexes that you have on the table, and key is any indexes that was used in the query on the table. So here we had no possible indexes, nor did we use any indexes. And as a result, we scanned a lot of rows, almost 400,000 rows, right? So we can create an index, create index last name on runner. It creates it successfully. So that should help us out in the future. So one thing here is you need to use indexes appropriately. You may need to make sure they're on your tables, etc. And so after the fix, I can run the same explain plan, and I can see that the possible keys now include last name. The key last name is being used in the actual query, and now I'm only actually looking at 45,000 rows instead of 400,000 rows. So now we've gone through all of our tools, and here you can see we filled out our entire chart. You can see that there's a lot of tools that provide you that thread info, GC, and memory information. And there's a couple tools that provide you that app response time, DB response time, and error information. And there are two tools, NewRelic and Yourkit, that actually have a star in every row. So one of the next questions to ask is what's the impact these tools are having on your application? Do they all slow down your application the same amount, or does it vary? So the answer is that it does vary. Here you can see the application response time. So what's the impact of the tool on your application response time? So just basic logging really isn't going to have much of an impact. Now if you use Spring AOP and you wrap every single method and log all that timing information, you're going to see an impact there, but just basic logging isn't going to really provide too much of an impact. Just basic JConsole, it's also not really going to have too much of an impact, nor is your admin console. And jvisualvm without a profiler, so it's really just doing similar stuff to JConsole, so it's not going to have too much of an impact. JStack, that's what does the thread dumps, that will have a low impact. And NewRelic also is designed to be run in production environments, and so it has a pretty low impact on your system. Yourkit, even without a profiler, I found it to have a relatively high impact on your application response time. And the same thing with jmap. So jmap's doing a heap dump, and heap dumps in general are just going to have a large impact. And both the tools that are a profiler, when you actually run with the profiler, that's when you see the really high impact. There's a significant slowdown to your application. So for production, logs, JConsole, app server monitoring, jvisualvm, JStack, NewRelic, those are all tools that are pretty good for production. Meanwhile, these other tools, Yourkit, jmap, jvisualvm, any really intensive profiler, you really want to restrict to your development environment. Now, one thing you'll notice is that none of the production tools really do a heap dump, and that's because heap dumps are expensive. So sometimes, if you just really need a heap dump, you're going to need to use a tool in production. So something like jmap can work for that. So I've gone back to our basic information chart here, and I've added a new column for production that will provide what we were just talking about essentially. Which tools can be used for production and which tools you really should just restrict to your development environment. Yeah?
So most of these tools, they work on any JVM, or there are only certain types of JVM they have been tested with? Like NewRelic or?
So NewRelic should work on any JVM. Most of the other tools, they come with the JDK, so those can pretty much, and really they should work on any JVM. I don't think any of the tools that I've listed are restricted to one JVM in particular. So I encourage you to add a new tool to your toolbox. We've looked at a variety of tools today, and that's basically the main takeaway. And also, use the tools sooner rather than later, because you need to learn how to use the tools before you need them. Because ultimately what we want are happy end users. So go try a new tool. And just a few comments here. NewRelic is hiring if you're interested. And we do have a user conference coming up in October also. If you're interested, there's the link to the website there where you can get more information. So now, does anyone have any questions? Would anyone like me to pull up any of the tools and just click through pages, look at things like, oh yeah?
Yeah, do you have any examples of monitoring or performance checking for predictive problems instead of, when your end user calls up and complains, go find the problem?
Yeah, so... Yeah, yeah, definitely. NewRelic in particular is good for that. So it's tools that can provide alerts, right? Those are the ones that they can alert you in time before that end user calls you and says, hey, your site's down. So generally APM solutions can provide you those alerts. So one thing like NewRelic, it generally is good at showing you what your norm is, and so you can see things like those spikes. If you look at it every once in a while, you could see, hey, my heap space is constant. Oh, wow, it's just starting to go up. I should probably go look at it. But it also provides alerting information too, so that you can get those alerts in time before end users start calling you. But the JDK tools are not going to provide alerts for you. Yeah?
Early on when you were explaining Yourkit, at the end, when you solved the problem at the end, you said you cleaned up memory. And you went over it kind of fast, but I didn't see what you did.
Yeah. So you're looking for the code examples?
Well, it was probably the last slide you did when you were talking about Yourkit.
Yeah. Yeah, so these are essentially just the capture memory snapshots, and let me actually, I have it right here. So you can go into your process, and it's right here, the capture memory snapshot. And you can click on that, and that'll capture your snapshot. And you can go ahead and open it up. And so now I don't have that. I've solved that issue already, so you're not seeing it here. But you can see that the char arrays are taking 33% of your time in memory. And this isn't the best screen for displaying, but so you can still see hash maps are taking 12%. So is that pretty much what I was showing you on those charts.
But what can you do about it? Go back to the code and solve the problem?
Yeah, so this is only going to show you where in memory, like where the object is in memory. So then you have to really go look at your code and figure out what's going on. Any other questions? Okay. Does anyone want me to pull up any of the tools, show them in live? Okay. Thank you very much.